Hey guys, welcome to my YouTube video today where I will be reading the strategic case study to you. The strategic case study for the November 23 and February 2024 sittings. The strategic case study exam is on a Preseen material from a company called RoboBryce. I'm going to be reading the Preseen to you today so you can follow on the screen and you can listen in. I've done this because reading is one skill, and that's how you learn things. Reading is one skill, absolutely. Listening is another skill, and watching is another skill. And I wanted to help and support as many CIMA students sitting this strategic case study as possible so that you can soak in different ways of learning. You can watch and learn, you can listen and learn. You can be in your car and listen. You can be out for a walk or a run and listen. You could be in the gym and listen. You don't always have to have it in front of you reading. All I will be doing is reading word for word from the PDF. You'll see that in a moment. And I'll tell you which page I'm on so that you can go back to this video at any point you need to. I'll be reading it so that you can soak it in, embrace it, and learn your Preseen so that you can pass your exam in February. You can do this. Any questions, please leave them in the comments and enjoy. I will be reading the Preseen word for word exactly like it is so that you can learn it properly, focus on the words and learn what you need to so that you can pass, right? Are you ready? On page 2, we have the introduction. RoboBryce is a quoted company that creates solutions for handling objects, primarily in warehouses and factories. RoboBryce assists its clients by developing and installing the systems required to store and retrieve inventory. For example, RoboBryce might support an online retailer by supplying a system that can pick goods from storage in response to customers' orders. You are a senior manager in RoboBryce's finance function. You report directly to the board and advise on special projects and strategic matters. RoboBryce is based in Testland, a developed country that has an active and well-regulated stock exchange. Testland's currency is the T-dollar. Testland requires companies to prepare their financial statements in accordance with International Financial Reporting Standards, IFRS. Page 3, warehouse handling. Many entities rely on warehouses for the support and management of significant quantities of parts or goods. The average area of a warehouse in Testland is 1,500 square meters. More than 40% of the country's warehouses exceed 9,300 square meters. Some organizations have warehouses of up to 95,000 square meters. Larger warehouses can simplify inventory management by enabling large quantities of particular items to be stored together. Their size can, however, complicate the management of the warehouses themselves. The largest warehouses can require more than 1,000 staff who may have to cover distances of hundreds of meters in order to retrieve each item required to fulfill a dispatch instruction. Warehouses often store many different items that must be kept safe and accessible. The design and equipment of warehouses can have a significant impact on the efficiency of their operations and on the associated costs. There are storage options with pictures. Picture 1. Goods are often shipped on wooden pallets, which enable them to be lifted by forklift trucks. Pallets enable efficient loading and unloading of delivery vehicles and the movement of goods within warehouses. Pallets are a standard size, which simplifies the management of inventory. Picture number 2. Containers. Goods that are transported in shipping containers are rarely shipped on pallets because the pallets themselves would typically require up to 10% of the available volume inside a container. Warehouses receiving such goods often load them onto pallets on arrival to enhance the efficiency of storage. Picture 3. Block storage is the simplest way to manage palletized loads within warehouses. An area of floor space is designed for a particular item, and pallets are stacked on top of one another. Block storage relies on the goods being strong enough to stack. They must also be held in sufficient quantities to make a stack worthwhile. The product must also have a long shelf life, so there is not a consistent need to unstack pallets in order to use the oldest inventory first. Block storage is inefficient if products cannot be stacked because it wastes the overhead space. Warehouses generally have high ceilings, and it is desirable to make the best possible use of that height. Page 4, we have more pictures. Picture 1. Warehouses are often fitted with racks that enable pallets to be stored as single units and make full use of the available ceiling height. Each pallet has a specific location that is directly accessible. The aisles between racks are usually 3 meters wide, which permits forklifts to access them and insert or extract pallets. Wider aisles are sometimes used to enable larger and more powerful forklifts to operate, although that arrangement will reduce the number of racks that can be accommodated. It is possible to have narrow aisles, creating more space for storage, but that requires the use of narrow aisle forklifts that cost more to buy and require skilled operators. Picture number 2. There are various specialized racking systems that can store pallets several units deep. These include racks with lanes that enable forklifts to drive into them, and racks with rollers that enable forklifts to push additional pallets in from the front. These systems enable much more efficient use of space, but at a cost in terms of flexibility. Only the pallet at the front of the rack is immediately accessible. That should not be a problem if all pallets in a row contain the same product, but it could be necessary to extract a particular pallet because, for example, it has goods that are closer to their expiry date. In that case, all of the pallets in the front must be removed before it can be accessed. And the last picture. Some smaller items can be stored more efficiently in cartons. They are stored on shelves. Shelves can be configured to store different combinations of weights and carton dimensions. Going on to page 5. The organisation of warehouses can have a significant impact on their capacity. For example, a warehouse of 1,000 square metres could accommodate the following numbers of standard pallets, depending on configuration. There's a table which shows the levels of racking, the size of the aisle, if it's a wide aisle or a narrow aisle, and then the full depth with push racks. I would understand this table when you're ready. These are maximum capacities. It can be difficult to operate a warehouse efficiently if it is at 100% capacity. It may be preferable to aim for 90 to 95% capacity. Warehouse picking, picker to goods, P2G. Picking is the process of obtaining goods from the warehouse and preparing them for dispatch to the factory or to a customer. Picking is affected by the nature of the business. Goods may be picked as entire pallets, whole cartons, individual items. In each case, picks may be multiple of pallets, cartons, or items. The nature of the business could also affect the number of items in a typical pick. Some warehouses may have to fulfill orders that consist of multiple items, and online retailers' customers may order several products, each located in different areas of the warehouse, at once. A supplier of vehicle parts could receive orders for 90 to 100 line items that are required urgently by car dealership workshops. Page 6. Picks can be organised in different ways. Number 1, individual order pick. A picker is given responsibility for a single order, collecting all of the items and returning to a workstation to prepare the order for dispatch. This approach is simplest. It is likely to be the fastest way to prepare any given order. The picker is dealing with only one order at a time, and so there is no risk of an item being added to the wrong order and sent to the wrong customer. It may be necessary to walk or drive a forklift over a significant distance if there are several items on the order that are stored at some distance from another. This is a particular problem if orders comprise small numbers of items, because pickers will have to return to their workstations frequently, creating a great deal of unproductive time. Sometimes orders will consist of items that cannot be combined with anything else. Perhaps an entire pallet has to be picked and creates an entire load for a forklift or for a picker's trolley. Pick number 2 is a cluster pick. A picker is given multiple orders at once and picks items for each of the different racks and shelves. The picker then can then fulfill several orders at once, increasing productivity through reducing walk times for each order. This approach may work well for an online retailer whose customers tend to order a small number of products at once. There is an increased risk of errors with items being placed in the wrong order when the picker returns to the workstation and prepares orders for dispatch. Pick number 3 is a batch pick, which is items for a number of orders are picked and brought to a secondary handling area where a further pick allocates items to individual orders. This approach might be suitable when certain products are ordered frequently, such as a retailer that has discounts on popular items. Pick number 4 is a zone pick. Picking is subdivided into zones. For example, an online retailer of electrical goods may set aside separate zones for large kitchen appliances, small kitchen appliances, and electronics. Each item in an order would be picked separately from its retrospective zone, and the goods would be combined as appropriate in the dispatch area. Page 6 still. These approaches are known as picker to goods because they involve pickers walking to or driving around warehouses while collecting goods to be prepared for dispatch. Items that are small and light may be carried in tote boxes or trays. Heavier items may be placed on trolleys, which can be driven by electric motors and steered by the picker. Picker may use a forklift for even larger items. Pickers can also be supported by collaborative robots, cobots, which carry goods that have been picked by the human picker. The cobot is a powered trolley which guides the picker to the location of the goods that are to be picked. The cobot displays the items to be picked on its screen upon arrival at the location. We're on to page 7. The picker can then stack the items on the cobot before it departs for the next location. The system is suitable for medium to large items. It improves efficiency because the picker does not have to return to a workstation after picking each item. Next, underlined header, warehouse picking, goods to picker, G to P / robot to goods, R to G. So we have G to P and R to G. Picking has traditionally been a labour-intensive process because it has proved difficult to automate the retrieval of goods that are different in terms of size and weight. There are, however, new technologies that enable goods to be collected and delivered to human operators for packaging and dispatch. These technologies are often referred to as an automated storage and retrieval system, ASRS. Automation offers a number of advantages. Faster than human pickers, less likely to drop or damage inventory through mishandling, enhances security because fewer operators have access to the stores, reduces risk of injury by collecting and transporting items mechanically, and fewer picking errors. Picking can be automated in several different ways, in particular through the use of carousels and robots. Carousels are used to store different products that can be brought to their operators' workstations to fulfill orders. Inventory is often held in storage bins that can be transported either vertically or horizontally, depending on the design of the carousel, to deliver the correct bins to operators' workstations. Goods require that orders are collected and the carousel deliver the next bin. Horizontal carousels can be configured in a number of different ways. They can be highly effective means of transporting goods around a warehouse and in facilitating picking of goods. Horizontal carousels can be adapted to store and present hanging garments or different types of container other than open bins. Vertical carousels are essentially a type of industry shelving that can be rotated so the relevant item of inventory is brought to a convenient height. Pickers are less likely to be injured by having to bend or stretch in order to retrieve them. There is also no need to use ladders to retrieve items that are out of reach from ground level. Some carousels have robotic picking arms that can collect goods, potentially increasing the speed of picking and reducing the need for human operators. Robots are generally more flexible than carousels. Warehouse robots are electrically powered and can move independently. Some have the ability to lift items for picking. Warehouse robots that lack onboard intelligence are known as automated guided vehicles, AGVs. They can operate automatically but require guidance. Automated mobile robots, autonomous mobile robots, AMRs, are more flexible. They have the ability to map their environment and to plan their routes. One significant difference between AGVs and AMRs is that the latter can be bypassed an obstacle. An AGV that encounters an obstacle in its programmed path will simply stop until the way is clear. On to page 8. Robots can automate the goods to picker approach by collecting a pallet or bin containing goods from inventory and bringing it to the designated human operator's workstation. The picker will then pick the parts required for the order or orders that are being processed before the robot returns the pallet or bins to its space in the warehouse. The system is more flexible than the carousel approach because several robots can be programmed to converge on any given workstations with significant spacing to prevent bottlenecks in picking. Some robots can pick items from inventory and deliver them to the next stage in processing the order. This is referred to as robot to goods, R2G. Mobile robots can be guided in a variety of different ways. 1. Linear route robots follow a path that is embedded in or is placed in the warehouse floor that can simplify navigation and reduce the risks of collision. The routes can take the form of rails or wires. Wires can generate a magnetic field that enables robots to draw electrical power by induction, which eliminates the need for robots to return to charging points in order to remain operational. The flexibility of these robots is limited by the need to lay out additional rails or wires in order to create new routes. They cannot bypass obstacles that have been left on the route, which suggests they are better suited to AGVs rather than AMRs. AGVs are generally cheaper than AMRs, so that is not necessarily a disadvantage. Number 2, barcode-guided mobile robots can navigate flexibly, provided the environment they are leading in has the necessary barcodes in place. Lasers on the robots can be used to read labels and so to identify objects that have been mapped, such as shelves and doors. The robots use electronic maps to plan routes to shelves that are collected and transported to the relevant workstation. And page 9 has a diagram for shelf units in storage and robotic shelving systems with the workstations. Please review this diagram at your leisure. Number 3, laser-guided mobile robots navigate using lasers to determine their position relative to objects. The simplest system uses mirrors that enable robots to determine their location on the floor, which is mapped, and so enables them to plan and follow a route. More sophisticated systems can create their own 3D maps, enabling them to identify objects, determine locations, and avoid obstacles. These systems are often used to relative large and heavy robots, such as autonomous forklifts. They are often used for transportation of heavy loads, such as full pallets, that often make them better suited to putting incoming goods in storage rather than picking goods for dispatch. That type of application requires robots to follow predefined routes, and so they may be better suited to AGVs for the sake of minimizing costs. AMRs that rely on laser guidance can be dangerous if they fail to detect human traffic. That risk can be dealt with by designating zones that robots are programmed to avoid and restricting pedestrian traffic to those zones. On page 10, we have coordinating movements of mobile robots. The nature of the application dictates the choice between AGVs and AMRs. AMRs are preferred when robots require significant onboard intelligence, including the ability to plan their own routes and avoid obstacles. AGVs are cheaper but are restricted in terms of onboard intelligence. They must be guided by a central system. Their sensors can detect unexpected obstacles in their path, but they can then do no more than stop and transmit an error message to the control system. They cannot navigate a route around an obstruction. And there is a flow diagram around mobile robot coordination. Centralized, distributed or mixed. In the centralized, you can see all robots are controlled by central software. This optimizes the use of facilities, and they are limited capacity because of computational requirements. In the distributed function, robots can make their own decisions. Conflicts can arise which cause delays. And they're highly scalable because individual robots control themselves. In the mixed level, this combines centralized and distributed. For example, tasks allocated centrally and robots plan paths. I would encourage you to review this diagram at your leisure. Also on page 10, centralized systems allow for the best possible use of robots and floor space. Software manages the operations of robots, allocating retrieval tasks to individual devices, setting paths and tracking locations. The software prevents collisions and avoids hold-ups by plotting paths and determining optimal routing. That could mean slowing a robot down or even making it stop briefly to permit another robot with a higher priority to pass. Centralized systems become much more complicated as the scale of the operation grows and the number of robots increase. That constrains the number of mobile robots that can be operated simultaneously. Distributed systems use AMRs that have been programmed to operate with a high level of autonomy. That relieves the pressure on the centralized control software because each robot determines its own path and manages conflicts independently. Mixed systems can be faster than centralized systems. They relieve the central control software of some of the burden of managing individual robots. Most complex automated warehouses focus on mixed control systems. Page 11, human-robot interactions. Some tasks can be carried out more efficiently by humans than by robots. For example, humans are better at removing plastic film from palletized goods or opening cardboard cartons and picking individual items from the resulting opened case. Humans may be required to work in collaboration with robots. A human might be directed by a particular aisle to pick items for collection by a robot. In that case, the sequencing of tasks for both humans and robots has to be managed so as to optimize the use of both, minimizing both idle time and the distance traveled between in the course of each shift. The design of robots should take account of their actions that will be undertaken by warehousing staff. For example, loading and unloading robots by hand can create the risk of accidents if the loading platform is at an awkward angle or height, or if there is a risk of items falling or injuring employees. Safety issues are also important when mobile robots and human work in the same areas. Collisions and dropped loads can lead to serious injuries. Robots can be fitted with sensors that enable them to identify the presence of humans. On page 11, there is a graph showing the market for automated warehousing equipment. The market for warehouse automation is growing, fueled by wide changes such as the growth of online retailing. For example, the global market for AMRs is expected to increase as follows. Please review the graph at your leisure. It shows the growth per year by US dollars in billions. That's on page 11. Page 12. Warehouse management systems. A warehouse management system, WMS, consists of software that monitors movements of inventory within a warehouse and ensures that inventory is managed and used in an efficient and cost-effective manner. WMSs support tasks such as storing incoming inventory and picking items in order to fulfill orders. Automated warehouse equipment, including carousels and robots, must be capable of integrating with the user's WMS system, both standard packages and bespoke package systems written to meet specific requirements. This is a great point to pause, guys. It was the first section which explained warehouse handling. That's the market and the industry that RoboBryce is in. I would pause right now and the next section is going to be us explaining what RoboBryce is and explaining, and I will be reading the RoboBryce piece of the Preseen, but I would definitely recommend a pause right now. Welcome back. We're on page 12. I will be reading from page 12, all about RoboBryce. RoboBryce was established in 1952 as a manufacturer of warehouse fittings and equipment. Developments in manufacturing and in traditional retailing, such as the introduction of supermarkets, encouraged the construction of large warehouses. The company has grown steadily since then, being quoted on the Tesla Stock Exchange in 1971. RoboBryce's initial product range focuses on carts and similar devices that could be used to transport goods. These were designed to be pushed or pulled by human operators. Over time, the product range was expanded to include shelves and forklift trucks. All production took place at a factory in central Tesland. RoboBryce has always taken an innovative approach to product development. Its shelves are highly adaptable and can be assembled and configured in many different ways. They can also be supplied with specialist fittings that enable them to store unusual products such as rolls of carpet. It has several different models of forklifts, including conventional, high reach, and narrow aisle designs. RoboBryce works closely with clients, advising them on the design of their warehouses so that they can be optimized in terms of capacity and efficiency of operation. RoboBryce introduced its first autonomous products in 2005. These proved commercially attractive despite the limited capabilities of these products that were available on the market. Warehouse operations were changing because of developments in logistics and in particular the growth of online retailing. Warehouse operators found themselves having to pick individual units instead of full pallets, as had often been the case before. By 2008, demand for autonomous products has grown to the point where RoboBryce decided to relocate production of its existing range of non-automated and non-autonomous products to a factory in Darland. Darland has a relatively weak economy and wages are low. Despite that, the country's educational standards are high, enabling RoboBryce to recruit skilled production staff for less than would have been paid in Tesland. The Darland factory continues to operate because there is a strong demand for its products. Warehouses vary in size, and it can be more efficient to use human operators rather than robots to run small warehouses, taking instructions from the WMS. Large warehouses may rely on mobile robots to facilitate inventory movements, but they often use traditional shelving for storage and low technology devices such as conveyor belts for transportation. Page 13. Most of the production equipment at RoboBryce's Tesland factory was shipped to Darland. The Tesland factory was then re-equipped for the manufacture of high-precision autonomous equipment. The Tesland factory makes extensive use of industrial robots for manufacturing and assembly tasks and for handling inventory and finished goods. RoboBryce currently employs 12,000 production staff, of whom 7,000 are based in Darland and 5,000 in Tesland. The company is one of the world's largest manufacturers of automated warehouse systems. It designs warehouse solutions on a global basis, supplying hardware and software in order to implement its designs. On page 13, we'll talk about RoboBryce's products. RoboBryce offers a wide range of products for use in warehouses. In the Darland factory, they offer forklift trucks, primarily optimized for use in warehouses, e.g. narrow aisle and high reach designs. Number 2, in the Darland factory, hand trucks, both open trucks and trucks with forklifts that can lift and transport pallets. RoboBryce's hand trucks are electronically powered but require a human operator to steer them. In the Darland factory, number 3, shelving. Modular shelving units that can be built in a variety of configurations that are suitable for the vast majority of warehouse layouts. In the Tesland factory, number 1, horizontal carousels, primarily suited to the storage and retrieval of limited quantities of goods that can be stored in bins or hung on rails, e.g. garments. In the Tesland factory, number 2, vertical carousels, primarily suited to store and retrieve goods on shelves from floor to ceiling. Goods are always presented at a suitable height to be lifted safely. In the Tesland factory, number 3, mobile robots. RoboBryce offers a wide range of mobile robots, including both AGVs and AMRs. It has robots suited to G2P and R2G roles. RoboBryce's robots are regarded as being among the most technically advanced on the market. Also on page 13, in addition to manufacturing warehouse hardware, RoboBryce provides customers with extensive consulting support in the design and installation and ongoing support of warehouse systems. The company employs 800 business advisors who can assist at all stages of the design of a new warehouse or the upgrade of a new facility. That support is vital because of the need to integrate autonomous devices with warehouse management systems, WMS. RoboBryce has extensive research and development activities focused mainly on autonomous products. Mechanical engineers aim to develop the physical attributes of autonomous products. These include enhancing the precision with which products can be picked without causing damage and the capacity of autonomous products, enabling them to carry larger quantities safely. Electrical engineers are interested in powering products that rely on electrical motors, whether they are autonomous or non-autonomous. Many of RoboBryce's products are powered by batteries and must be recharged at regular intervals. Ideally, these products should operate for as long as possible between charges, and the charging time should be as rapid as possible. Software engineers design software and write and test program code. RoboBryce's software engineers focus on autonomous products with a view to adding capacity and enhancing reliability. Warehouse developments such as new sensors and more powerful processors create a need for software upgrades that can make use of these opportunities. RoboBryce must also maintain its software to ensure that its products can continue to operate in conjunction with warehouse management systems. RoboBryce's research laboratory is located in the larger building besides the Tesla factory. The company employs 900 research and development staff, split equally between mechanical, electrical, and software. Also on page 14, we have extracts of RoboBryce's annual report. RoboBryce's mission and values. Our mission. RoboBryce's mission is to pursue the growth of our business in a manner that advances social well-being. Our vision. RoboBryce's vision is to enhance the efficiency of our customers and, in doing so, to add value to society. Our values. RoboBryce aims to enhance social well-being and the quality of life. RoboBryce aims to meet stakeholder needs. RoboBryce aims to innovate and be at the forefront of the implementation of new technologies. On page 14, we have RoboBryce's board of directors. Please forgive me for any pronunciation of the first and last name. Number 1, Professor Siddhartha Patnaik. He is a non-executive chair. Siddhartha is a mechanical engineer by training. He taught engineering at a prestigious university, rising to the rank of professor and dean of engineering at the University of Central City in Tasland. He served as principal of the university before retiring from academic life and joining RoboBryce's board in 2021. Siddhartha is a member of the Council of the Institute of Mechanical Engineers of Tasland. Number 2, Iwa Durska, Chief Executive Officer, CEO. Iwa worked for a major retailer as a logistics manager, eventually reaching the position of head of logistics before leaving the company to join RoboBryce as Director of Research. She has served as RoboBryce's Chief Executive Officer since 2021. Number 3, Eamon Macaulay, Chief Operating Officer, COO. Eamon studied electrical engineering at university. He joined RoboBryce in 1998, initially as a member of research and development before moving into production. He completed a part-time MBA during that period. Eamon managed RoboBryce's autonomous products factory from 2014 to 2022 when he was promoted to COO. Number 4, Phyllis Yildiz, Chief Financial Officer, CFO. Phyllis is a professionally qualified accountant. She has had a varied career working for several organisations in finance-related roles. She was chief accountant at a major manufacturer of construction equipment before she joined RoboBryce as head of treasury. Phyllis was promoted to CFO in 2020. Dr. Hassan Kataf, Director of Research. Hassan studied data science at Tesla's capital city university and completed his PhD at the University of Central City, where he taught and researched until 2016. He left academic life to join RoboBryce as a research manager. Hassan was promoted to Director of Research in 2019. Hoi Zin, Human Resource Director. Hoi studied Human Resource Management at university. She worked in the personal department of a major bank after graduating, during which time she completed the Tesla Institute of Personal and Development qualification. Hoi spent 5 years as head of human resources at RoboBryce's non-autonomous products factory in Darland before returning to Tesla as head of human resources. Hoi was promoted to Human Resources Director in 2023. Didier Airo, Senior Independent Director. Didier had a successful legal career working for one of Tesla's largest commercial law firms. He was a partner of the firm and served as managing partner for 3 years before retiring. Didier rejoined RoboBryce's board as Senior Independent Director in 2020. Nina Isabel Correa, Independent Non-Executive Director. Nina worked as an economist at the head office of a major bank for much of her career. She was involved in policy development for much of her time, rising to chief economist. She retired from banking in 2016, spending 4 years as a professor of economics at Capital City University. She joined RoboBryce's board in 2020. Nigel Taylor, Independent Non-Executive Director. Nigel spent most of his career working for a major management consulting firm that involved significant overseas travel and gave him a broad experience of working with manufacturing companies on a consulting basis. Nigel joined RoboBryce's board when he retired from the consulting firm in 2022. On page 16, you can see the board responsibilities. Ewa is the Chief Executive Officer, and these 4 report into Ewa. Eamon, COO, Phyllis, CFO, Hassan, Director of Research, and Hoi is HR Director. Please review this yellow table at your leisure. You can also see a green table which shows the board committees. We have the Audit Committee, the Risk Committee, Remunerations Committee, and the Nominations Committee, and which board member is on which committee. Please review this at your leisure. The Chief Internal Auditor reports to the conveyor of the Audit Committee. Page 17 shows RoboBryce's principal risks. There is a table of a risk impact and the risk mitigation. I will read one impact with its mitigation at a time. Please review this table as well so that you understand which impact goes with which mitigation. Number 1, customer demand within key business segments can be cyclical. Also, many customers are in industries that are highly competitive, which puts pressure on both investments and willingness to bear costs. That's the risk impact. The risk mitigation is RoboBryce pays close attention to all the available information about customers and adapts plans and budgets accordingly. The company also aims to be flexible and adaptable with a view to reflecting demand in managing capacity. Risk impact number 2. Customer projects can be significant and can take a long time to implement. That can lead to problems such as revisions to specifications by customers, difficulties in predicting costs accurately, penalties for late completion, and customers becoming insolvent during the project. The mitigation to that is RoboBryce assesses risk on a case-by-case basis and monitors progress closely throughout. Contracts are conducted in accordance with detailed specifications that allow for possibilities such as requests for changes and deliverables and the possibilities of a supplementary charge for any additional costs. Risk impact number 3. RoboBryce does business in many different countries, both as a supplier of warehouse products and systems and as a buyer of parts and materials. The mitigation to that risk is RoboBryce hedges currency risks as appropriate, focusing on the management of economic and transaction risks. And risk impact number 4, RoboBryce faces significant IT risks, both in terms of its own operations and in respect of the design and installation of automated warehousing systems that rely heavily on software for the operations of autonomous products. The mitigation to that risk is RoboBryce has systems in place for the management of IT risks. Those systems are kept under consistent review and are updated as necessary in order to minimize the IT risks. Risk impact number 5. The company depends heavily on its technical and management staff to ensure that it remains at the forefront of product development and can ensure that there is capacity to maintain the design and installation of customer systems. The mitigation to that risk is RoboBryce keeps staff salaries under consistent review and ensures that they are competitive in comparison to rivals. The company also invests heavily in training and staff development with a view to ensuring skilled staff have a clear career path open to them. On page 18, there is RoboBryce's consolidated statement of profit and loss for the year ended 31st of December 2021 and 2022 in $. I would ask you to review these numbers at your leisure. I will read out the numbers now for you to try and soak in and learn, okay? So in 2021, revenue was 13,867. In 2021, operating costs were 11,024. In 2021, operating profit was 2,843. In 2021, finance costs were 1,100. In 2021, the tax expense was 227. In 2021, the profit for the year was 1,516. In 2022, the revenue was 14911. In 2022, the operating costs were 11631. In 2022, the operating profit was 3280. In 2022, the finance costs were 1100. In 2022, the tax expense was 305. In 2022, the profit for the year was 1875. Also, on page 18, we have the consolidated statement of changes in equity for the year ending 31st of December 2022. I'll let you review this table at your leisure. It shows the profit for the year, the dividend, and the currency reserve, and the loss on translation. In page 19 is RoboBryce's consolidated statement of financial position at that 31st of December 2021 and 2022. We have our assets, our current assets, equity, liabilities, current liabilities, total equity and liabilities. On page 20, we have an extract from the competitors' financial statements. RoboBryce is one of 6 major companies that compete for the design and implementation of automated warehouse systems. Its most direct competitor within this market is PavRobot, which is also based in Tesland. PavRobot's manufacturing interests are restricted to autonomous products such as carousels and mobile robots. The company does not manufacture non-autonomous products. Indeed, it sometimes specifies RoboBryce shelves when it designs clients' warehouses. RoboBryce and PavRobot frequently bid against one another for warehouse contracts. On page 20, we can see PavRobot's consolidated statement of profit or loss for the year ending 21 and 22. Please review this at your leisure. You can see that in 2022, PavRobot made a higher profit for the year than RoboBryce. Also, we have a consolidated statement of changes in equity, where they also paid a dividend and they also had a loss on translation in their currency reserve. Page 21 shows PavRobot, which is the competitors. PavRobot's consolidated statement of financial position for 2021 and 2022. Please review this at your leisure. It's quite hard for me to explain and read it. Your eyes might need to see these to understand the numbers and the layouts. On page 22, we have a share price history for RoboBryce. Share price, that's a graph showing RoboBryce's share price since 2018 to 2023. You can see the fluctuation in share price. RoboBryce's beta is 0.91. On page 23, we come to the news stories and articles at the back of our Preseen. Article number 1 is from Happy Comic. It's a reader's question. I watched a documentary about robots and was amazed that they can operate independently and still navigate without crashing into things all the time. How do robots do that? Asked Evan, age 12. The answer was, there are lots of different ways in which robots can avoid damaging collisions. The easiest is to use a bumper sensor, which is a simple switch that is hidden behind a bumper. The switch is pressed if the bumper hits an object and the robot stops. The robot will then respond to the obstacle according to its programming. It could send a message that has stopped and will await electronic instructions, or a human operator could reposition the robot and reset it. Or the robot could be programmed to reverse a short distance and turn slightly before setting off in a slightly different direction, hopefully avoiding the obstacle. The most complex robots use LIDAR, which operates in a simple way to radar, but it uses laser light instead of radio waves to scan ahead and create an image. If a robot has a powerful enough processor, it can interpret LiDAR images and use them to avoid objects or to identify the destination for a journey. LiDAR has the advantage of being able to delete objects before LiDAR has the advantage of being able to detect objects before a collision. With the right programming, robots can predict the course of moving objects and can take evasive action if there is a risk of collision. These are just 2 examples. Robots can be equipped with lots of different types of sensors that can be used to identify their locations, track objects, and locate specific items. Article number 2 is from the Tesla Telegraph on page 24. Article number 2 is from the Tesla Telegraph. Tesla Food operates lights-out warehouses. Tesla Foods has operated its first lights-out warehouse. This will be used to manage materials used by the company to manufacture pies and ready meals. The new warehouse uses horizontal carousels to store and transport sides of beef. The warehouse management system can select specific items to be picked within minutes of a request from the factory, so its inventory can be selected on the basis of its age and its quality. The warehouse was designed and installed by RoboBryce. The warehouse is referred to as lights out because it does not require any staff to work alongside the automated equipment. That means that the warehouse does not have to allow for the needs of humans during routine operation. In a cold store environment, that means there are fewer heat sources in the warehouse, which reduces operating costs because less must be spent on energy to power refrigeration. In theory, the warehouse could operate in complete darkness, with the lights being switched on only if a member of staff has to enter for maintenance purposes. On page 25 is article number 3 from the Tesla Telegraph. Supermarket price wars continue. Supermarket customers continue to enjoy price reductions as the 5 major supermarket chains continue to cut their prices in order to win market share. This is good news for customers, but less welcome for investors in supermarket shares. Industry experts believe that the retailers are making little or no profit on popular items. If the price cut continues, then supermarkets might actually start to incur losses at the checkout. Professor Marika Bogren is a leading economist, commented that the price war might appear illogical, but it is consistent with game theory. In game theory, each player's payoff is affected by the decision of others. Game theory assumes that players act rationally and in their self-interest. Supermarket boards might cut their prices in order to maintain sales volume and retain market share. If a rival reduces prices still further, then it might be rational to cut prices even further in order to avoid being driven out of business. Professor Bogren added that it would clearly be more rational for all supermarkets to set prices based on reasonable margins and for all to enjoy the benefits of a stable and profitable market. Sadly, game theory suggests that such outcomes are unlikely to remain stable in practice. Page 26 is your next article from the Tesland Daily newspaper, which is titled Mixed News for Warehouse Staff. Logistics work in warehouses has a reputation for being poorly paid and stressful. Workers often have to keep up with the pressure to process orders quickly and accurately. They are also at risk because of the need to carry and lift goods. Warehouse work is changing because of the increased emphasis on automation. Each new generation of robot adds capabilities with respect to their ability to conduct tasks that previously depended on human labour. Robots can pick items from shelves and transport them to workstations for processing. The processing might be carried out by a human, who can focus on packaging and labelling goods for dispatch. Alternatively, robots who carry out tasks that were previously too complicated for machines, including wrapping packages. Automation need not replace staff entirely. Collaboration robots or cobots are designed to work alongside humans using sensors to avoid accidents and injuries. Cobots can eliminate much of the heavy lifting that might have been required in some warehouses. There is no doubt that automation will replace many of the workers required in large warehouses, but the jobs that remain will be potentially more interesting and better paid. There will be a greater need for staff trained in IT and for engineers to maintain and repair the automated equipment. That is the end of the reading of the Preseen. That is the end of the reading of the Preseen of RoboBryce. Thank you for listening. Apologies for any grammatical errors or any stumbling. I am your revision coach. I am no perfect reader, but I wanted to record this for you because I know it will help some of you to learn and soak in the Preseen instead of reading it black and white on a piece of paper. So I will date stamp each section so that you can go back and rewatch it and re-listen as and when you need to, so that you can really soak in this Preseen in lots of different ways before your exams. Remember to listen when you can't access the pieces of paper. You can be on a dog walk, having a run, on the train. I know once you listen to this over and over and over, you will understand and soak in the Preseen. I would say it comes in two sections. Obviously, the warehousing market industry piece was a large, big section. And then the RoboBryce was the second big section with a little bit about Pav Robot at the end and the articles. The articles are very important, guys. Do not miss those out. Know them, understand them and read them. If you are sitting your strategic case study in February 2024 and would like some Helen coaching, I would love to help and support you. All you need to do is leave a comment, contact me on LinkedIn, or help. I have some coaching if you need some help, I have some coaching opportunities for you. I would love to help and support you so that we can write about RoboBryce, we can analyze it, and we can be the senior finance leader in the boardroom discussing the right RoboBot points that will get you marks for your February exam. Hope you've enjoyed the reading, guys. Thank you so much for being here. Like and subscribe for more revision content, and I'll see you soon. Thank you.